So what I want to touch on now is we all like that sci-fi kind of Tom Cruise moving data around and spinning dials, all that kind of thing. That's all really fun, and I think everyone kind of likes to imagine that future where you're basically futuristic. But to support, and that's what got me into space. Honestly, if I was, in all honesty, I can pretend that I'm a futurist and I saw it, but really I was just like, I just want to be surrounded by gadgets and gizmos, and I'm like, basically a sort of digital wizard. And then after years and years of being in the space and I guess refining my tools, the biggest lesson I've learned is like, all right, what is this for? Have I got a solution looking for a problem kind of thing? So what I want to touch on now is some of the data that drives the need for new interfaces. It isn't just a matter of, oh, it's cool. It's actually a matter of, hey, there's these trends that mean we need new ways to interact with data. So, digital twin is the space that I've been working in a lot for the past year and a half, I think, working with people like the City of Melbourne, with Telstra, Google, Singapore Museum, for example. Basically, there's two things a digital twin is. A digital twin is a data set to do with pretty much anything. Right now, you can essentially have a digital twin of this event where we would be able to track attendance, who was there, who wasn't there. It's really just a table, a data set. And this is kind of where we got to with our research project with Telstra was, well, let's put a box around what a digital twin is. And so we defined a digital twin as a data set relating to people, spaces, and devices. So a digital twin might be the position of the light sensors in the room, but it can also be combined with the way that this entire floor is used as a classroom. So essentially what we need to see is that we need to find a way to use this data, and we need to find a way to make it meaningful. So with our project with Telstra, we'll cut to the hard facts. Essentially, the challenge that we're given is that there's this push and this trend and this actual real use case for Internet of Things. So I've always imagined Internet of Things. What would be the first thing someone shout out what they think of when they hear Internet of Things? Fridge. Same, right? Everyone's just like, all right, a fridge that just has milk and that's it. Let's build this Internet of Things enabled future so that a fridge knows how much milk you've got. But what's actually happening is we've got the infrastructure of our entire economy is supported by these increasingly more intelligent devices. And their particular client that we were doing the research project with was basically waterworks. So they have these pipes and gizmos and gadgets and engines, and they need to be able to, at any time, check on the status, the health, water flow, things like that. And the challenge they gave us is how could we bring that data to life and make it more meaningful? How could we take a bunch of data points on a table and then display that as part of their environment? So what we were playing with and experimenting with was, okay, cool, we've got this device that's intelligent. In the old days, we would have given it dials and we would have given it buttons, we would have given it levers and things like that. In the current day, we probably would have given it a companion app where you see, is it on, something like that. By creating a digital twin of these devices, what we're able to do is contextualize the data a lot more. So instead of seeing, all right, I've got a thermometer, I've got a temperature reading here, you're actually literally able to, in the space, go up and say like, okay, cool, this is the temperature of this pipe, this is the water flow of this pipe. Internet of Things is an incredible part of most digital transformations for cities. So as we develop our cities, as we're workshopping with the City of Melbourne, we're going to have this incredible data set, all coming from sensors, devices, cameras, but we can't see it. Who's going to be able to see it? The Melbourne City of Melbourne has an incredible open source data set. I can go on right now and build an app that finds out where every fountain is in Melbourne or where every free car park is in Melbourne. It's amazing. So what we really, the way we see extended reality and spatial computing interfacing with this is it suddenly brings this data to life. Another area where visualization, spatial computing, digital vision we'll call it, comes into play is artificial intelligence. So one of the biggest trust vectors with artificial intelligence, one of the blockers to it becoming a part of people's everyday life, is the ability to understand its decision making. A lot of studies have been shown that, for example, doctors that are taking guidance from artificial intelligence, if they can find some way to visualize or understand the way the artificial intelligence has reached its decision, they're more likely to trust it. They're more likely to use its diagnosis as part of its as part of a healthy treatment plan. So, a really good example though is in driverless cars. Dodge the mic. Good job. So, imagine the world of the future where you're walking around and it's essentially blank machines moving around, zipping between traffic, delivery drones, cranes picking people up. Maybe that's probably not the best form of transport, but most importantly, driverless cars. How comfortable would you feel? No drivers, boxes zooming around, zipping past, coming down here. How comfortable would you feel walking out on the street, even if you knew that they were going to dodge you? Would anyone blindly walk out onto a? I've got a shake of the head. Cool. Thank you for supporting my. It was a bit of a loaded question. I don't know what I would have done if you said yes.
It's just a matter of time because people wouldn't normally get on an escalator, but they do it every day, right?
Yep. I think so. Absolutely. But further to this, what about? Let's take the escalator example. What about if there was multi-speed escalator belts that only work because we've got super AI that knows where people should go where and zip over there? How is this AI, this incredibly super intelligent system, going to communicate with us, right? So that's where the ability to give people digital vision and spatial computing suddenly makes it possible for us to dismantle the black box that sort of encases artificial intelligence. And I think it's going to be a really, really big part of us not just trusting AI, I think that is part of it, is being able to visualize decision making, but also being able to meaningfully interact with an artificial intelligence. So for example, if you did have a home manager artificial intelligence that was linked to your Internet of Things enabled fridge and did liaise or acts as the liaison point for your what are we talking about? Driverless cars. It'd be a bit of a shame if you were just talking to a disembodied voice, or maybe that's fine for the moment, but it'd certainly be a shame if it was just like a sort of Telstra, iPad, T-Hub sort of thing. What you can really imagine is that artificial intelligences will surface interactions in maybe not necessarily humanoid, but avatars, and essentially your artificial intelligence, your Siris and things like that will be able to have conversations with you and be able to convey meaning to you in a way that you understand. So that's where spatial computing, I think, really gives us the ability to reconnect with these super hyper intelligent systems that sort of engulfing maybe isn't the right word, but becoming such a part of the world that we live in today. So further to this, I think it's just really interesting that we are creating these artificial intelligent, avatars robotically, and it makes a lot of sense. It's really fun. We get to make mechatronic faces that are hyper realistic, but realistically, that's such a huge bottleneck to creating what is essentially realistic human-like expression and relationships with digital avatars. That's the whole point. That's the whole long game. Is you can talk to a digital, I won't say consciousness, but intelligence, and it feels natural. Not for them, but for you, because you will have a better conversation. You will function better when you're interacting with that AI when it feels naturally. And I see spatial computing as being integral as the interface to these hyper-intelligent connected systems. 2D screens and infinite data. And this is kind of the other piece of the puzzle is big data, where it all comes together and we suddenly do have the ability to track entire cities, and we have the ability to understand and predict traffic patterns. We have the ability to look at the way that social networks work and interact with economic models and stuff like that. If we just hand it over to AI, fine, it's great. We can just put it all in the little machine and it comes out with a little ding, there you go, here's your economic policy, here's your finished traffic patterns or whatever. But if we want to be able to interact with and get insights from big, rich data sets, we need new ways to visualize them. And the reality is that looking at charts, and even if they spin around or something like that, aren't that useful. As we make more and more complex systems, we need more abstract visual representations of them so that we can not just absorb them, whatever you call looking at things. Sorry, absorb sounds a bit like I'm an alien. I know how eyes work, but also interact with them differently as well. And I'll talk on what spatial computing is to me in a minute. But it's not just being able to look at 3D objects. It's about being able to interact with them naturally, receiving the ability to touch and glance and things like that as well. Soon your computer will know when you sigh, because it's taking too long. So how about sigh-based input? So I thought I'd throw this in. This is a bit of this is more of a cartoon of what it would be like, but you can imagine being a data systems engineer and trying to actually debug an incredibly complex global system. This might speak to a taste of what that future could be. Let's skip ahead. I don't want to watch the whole thing. It's cool, it's a good video, but I feel like they'd be like, come on, you're obviously stalling for time if you're putting on videos. Alright, here we go. Oh, very dramatic. I did listen to it with the music on and realized it was so exciting. Cool. So that's the future. There we go. Thank you, everybody. You've been great. I guess what you can take away from that, though, obviously that isn't necessarily, you're not going to, well, maybe you will. Like, has anyone here read Neuromancer? Yeah, you guys get it. And everyone gets it. It's good. You will soon. Though it's pretty dystopian. It's funny because I'm like, I love all this dystopian sci-fi, and I'm just like, why don't want to live in this nightmarish corporate digital hellscape, but I do want to live in sort of like a digital infinite, or at least have access to an infinite digital creation space. So it's a trade-off. Anyway, that's not on the slides. Speaking of which, let's get that back off. Magic Leap, one of the main creators of, well, one of two creators of effectively available wearable spatial computing, which we'll define in a bit more detail. But they talk about this idea of the magic verse, but it's essentially this interconnection of all these different systems, of AI, of IoT-enabled cities that then dial down to IoT-enabled buildings that also themselves have an understanding of you, not in a sort of scary panopticon kind of way where McDonald's is watching where you walk and things like that, but more in a way of, if we go back to that idea of a digital twin, places, devices, and people. I think that's a really easy way to slice it up. That's the definition that Microsoft uses for their Azure digital twin platform. So in this world, it won't just be these abstract systems where you've got the driverless cars and you've got the water pumps down below. They're all interconnected and they all have a relationship with each other, and they all have a relationship with you and the devices around you. And with spatial computing, we will be able to utilize that digital layer. These digital layers already sort of exist. There already is sensor data about the car parks that are available. There already is ways to visualize the decisions that autonomous machines are making. There already is information about traffic patterns. Your Google Map is a digital twin of the city right now. It has a very rich data set. It's really just a way of bringing that this city that's just bubbling with information to life and putting it at your fingertips. But we can't do it with our mobile phones.